Hello all, welcome to this class on projection of solids. And in this class, let's solve the first problem in pyramids. So far we just solved many problems in projection of solids. By taking different prisms problems like square prism, pentagonal prism, hexagonal prism, etc. So in this class, let's try to solve this problem on pyramids. So in pyramids, you can just see the first thing what we'll have to identify in any problem is identify whether what kind of a solid it is. So whether it's a pyramid or a prism or a cone. And in this problem, it's a pyramid, and the shape of the pyramid is a square pyramid, and it's resting on one of its corners. So first of all, let me tell you what's a pyramid. So pyramid in the sense its base will be of some shape. For example, in this problem, they are telling it's a square pyramid, so therefore its base will be of square shaped, and all its lateral surfaces will be of triangular shapes. So in prisms, all its lateral surfaces were of rectangular shapes. That means all from each of the corners of the square shape base. If you just try to project it, and all those projections will meet at an apex, and so therefore all its lateral surfaces will be triangular shape. So its apex will be just a point, and its base will have a true shape. That is, in a square pyramid, a base will be of square shaped. So let's proceed with this problem. So usually pyramids problems are much easier compared to prisms problem. So let's try to draw the reference line first. So xy, and let's try to name that using caps. So let's name this x, and let's name this y, and let also name it vphp. So see that vphp is also named. And next thing what you'll have to do it is draw the square pyramid. So square pyramid, they're telling 35 mm side of base. So using a rectangle and a visible line, let's try to draw it. So let the width of this square be 35, enter. Height 35, enter. And they're telling the pyramid is resting on one of its corners. So for corner condition, always give 45 degrees. Enter and place it somewhere here in the top view, that is below the xy line, somewhere like this. So now you can just see the pyramid is drawn. So now let's try to name the pyramid. As I told, only its base will have some shape. So only the base can be named. So there is nothing like a top face now. So let's try to name the base as A. So see that the caps are switched off. A, B, C, D, A, B, C, and D. So now even the center of the prism have to be drawn. So in prisms we usually draw these centers by using this visible line. So see that if you try to place the cursor somewhere here, the center line can be, the center point can be obtained. So just, or else you can just draw those, using the diagonal lines, you can try to draw it also. And because in a square it's much easier, you can just draw the diagonal lines using visible lines itself, and then try to trim it also. So then try to trim it as well, nothing is going to change. So you can try to trim it now, so you will get it the same. So now we go to text option and try to name that O01, because the base is named O while the apex is named O1. So apex will be hidden, so that's the reason why it is named like that. So now let's try to draw the front view. So first normal lines, projection lines are drawn up to this reference lines. So from each of these points, so let's try to draw that. So now from here, so let's go to this center line. So we just don't just draw it using center line, because as this is pyramid, we'll try to draw it using sometimes here center lines also can be drawn using the axis lines are drawn using center lines, but here it is a corner condition. That means in the front view, when you see, everything will be visible. So just go to a visible line, and from here, so let's try to give the axis length as 60, enter. So now just join this from here, join it. So this one will be an apex actually. So as I told, in the front view, when you see, it will be an apex. So just join it like this. So now you can just see you can just zoom it also. So it is still fine. So now we will have to name it. So this one will be A dash. So let's try to name that A dash. So A dash. Similarly, when the observer sees from here, B will be visible, while D will be hidden. So let's try to name this B dash, and in the brackets D dash. And similarly this one. If there are any mistakes, see that we are trying to do it correctly. You can just see here there is a small mistake over here. So let's try to draw it correctly. So if it is not fine, you can try to redraw it. So see that some mistakes, you are trying to avoid such mistakes. So now it looks fine. So you can just try to name this B dash D dash is fine, and this one as C dash, and this one as, so you can just see here the apex will actually be named O dash. So O dash. Okay. So when he sees from here, even this O will actually be hidden. So even here, O will also be drawn. So O dash within the brackets. So O dash. Else you can just skip, try to skip that. That's not an issue. So now that completes the first stage of the problem. Now to draw the second stage, let's try to select this and try to move it. See that the copy is switched on. So just select from one of the corners from this corner and try to place it here. So just place it over here. So well, after that you can try to delete these points. Else you can just using control key, you can try to select only those lines and try to place it also as well. That will also be a good idea. Now we can just see, draw the projections of the pyramid when the axis is inclined to HP at 40 degree and VP at 30 degrees. So now we'll have to rotate this. So go to rotate. So try to select this. So try to select this. So now it's very important which one to click as the center of rotation, where to rotate from. That is very, very important. If you just look at in a prism, yes, this endmost corner, that one we are just selecting as a center of rotation. Yes, even here, even in a pyramid, we just do the same thing. But you can't select this corner because this is an inclined edge in a pyramid. In a prism, you can just see this, that was a very straight or a parallel edge, but here you can't select this. So we try to select this edge which is parallel, but so when we are trying to give angle, we are trying to give the rotation angle, not the position angle. So rotation angle will be like, so you can just see here it is given as inclined to HP at 40 degrees. So we directly don't give 40 degrees, we try to minus it from 90 degrees. So 90 minus 40 will be 50, and rotation angle will actually be given 50. But if you look at in prism, we were trying to do the opposite, or whatever was given we were trying to enter, and we were trying to give the position angle as that. Suppose if this the same problem, instead of pyramid, if it was a prism, we would have given position angle as 40, but here rotation angle is given as 50, and just try to enter. You can just say we have just got it. If you want it, you can confirm it by clicking the angle between these both, and you can just see this is trying to be 40 degrees. Yes. So now let's try to move those points. So see that the copy is switched on. So see the copy is switched on and all these points are moved. So all these points are moved, and now let's try to draw projections. So projections will be much easier. As I told, there won't be too many projection lines to draw. So A dash to A1 dash, similarly from B dash to B dash to B, C dash to C, while D dash to D and D dash to D, and O dash to O. So O dash to O. So now let's try to name those points. So see that so you can even move those points as well, because there are just only single points here. So see that the copy is switched on. So A dash to A. So this one will be A. Similarly, B dash to B, this one will be B. C dash to C, this one will be C. D dash to, so see that the point is correctly selected. So if you want, even you can try to zoom it and try to select it, so that while if you zoom it and try to select, you can correctly select it. So D dash to D, so this is D, and O dash to, so you can just see this is O dash to O. So this is O. So let's try to name this O. So now you can just see all the points are selected. So you can just see now when the observer sees from here, from the top, this point will actually be visible. That is O to C. That one will completely be made visible. So you can just first draw the the boundary. So here there is no top and bottom face, so there won't be anything too much complicated in this. So first thing what you can do is just join the boundaries using visible lines. So go to line, visible line. So just join these boundaries first. So the boundaries can be joined first. Next one is which one to be made hidden. So you just see the endmost point. A dash is the endmost point. So A to B and A to D, A to O. A to B, D and O must be made hidden. So A to B, D and O. So go to hidden. Go to this thickness, you increase it 0.5. A to D, A to B and A to O. So A to O will be made hidden. So let's try to go to a hidden line 0.5. So A to O. And just see which one else to be made. And O to C will be made completely visible line. So O to C, already there is a hidden line drawn. So when you try to draw it using a visible line over that, so visible line is what will prevail. So O to C actually must be drawn using a visible line. So you can just see now that is visible. That completes the second stage of the problem. So now let's try to draw the third stage. So before drawing the third stage, let's try to measure this axis length. So you can just see initially the axis length was found to be whatever that was given. So using the smart dimensioning, you can let's try to identify that. So let's using smart dimensioning. So it was given as 60. So now if you try to measure this axis length, so here between you can use this distance between. So you can just see it is not so exact. It is 45.96. You can just see here. So if it, the axis length has reduced from first stage to second stage. That means this is nothing but an apparent length. So when there is apparent length, there must be apparent angle as well. So you can't take the same angle 30 degrees. You can initially take it 30 degrees, but you can't incline this pyramid at 30 degrees. We'll have to find out the apparent angle and then try to incline that pyramid at 30 degrees. So let's try to do that. So first what we'll have to do it is, so first try to draw this inclination line using a normal line. So let's try to draw an inclination line. So let's try to draw a line like this. Else let's try to draw a parallel line, and let's try to do that. So let's try to zoom that and make it 30 degrees. So go to angle between. So that is 30 degrees. So let's make it 30 degrees. So suppose if you aren't getting it, let's try to. So you can just zoom it and try to draw it a little more. So now you can try to measure the angle between this. So 30 degrees, enter 30 degrees. Okay, we aren't getting it. So let's try to do it much better. So let's try to do that. So let's try to draw a line from here. Suppose you can just even try to do it from here as well. Sometimes you might get it. So let's try to give the angle as so give it 30 degrees. So yes, we have just got somewhere like this. So that's fine. So let's try to fit it. So now let's try to, we'll have to place this prism over here. So but before placing it here, we'll have to identify this apparent angle. That is very important. So what we'll have to do with this, you see the apparent angle, you can just see initially the axis length was 60, later you can just see the axis length has been reduced to 45.96. So what you do first is, so for that you will have to find out the apparent angle. So go to this arc by center point. So see that okay, let's try to zoom that. So let's try to draw an arc here first. So this be the, so wherever we have drawn, let that be the center point of the arc, and let's try to draw the arc. Let's try to give the radius as 60, enter, and let's try to draw an arc here. So that is very important. So first let's try to draw that arc, and later on what you can do is, let's try to draw a line wherever it is cutting. You can just see it has cut the line here. Now let's try to go to this arc by center point again. Using the same center, let's try to give the radius this time as 45.96, enter, and see that it is trying to cut here, cut this line here. That means wherever it is cutting, just join a line there again. You can just see it is trying to cut here now. I mean, wherever it is intersecting that line. So now let's try to measure that angle. So the angle between this and this is found to be 40.68, that is almost 41 degrees. So at this line we will be placing this this axis line. So here is what we'll be placing. You can just see now at this 41. So you can just see the question. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and to VP at 30 degrees. So first we'll just place this pyramid here and then try to rotate this axis actually. So this axis OC, that one will be made that will be made inclined at 41 degrees or 40.68 degrees. Actually it was found to be 40.68 degrees. So now let's try to select that. So let's try to move it. So let's try to move this. So see that when you're trying to move all those center point, everything is selected. So here you can just see the center point is not selected. So what you can do is go to split and try to split this center point exactly here at the boundary of the pyramid. So you can just see this one has got completely selected. So let's try to select this pyramid now, whatever we got it in the second stage. So let's try to move that. So see that a copy is switched on. Let's try to move from this corner and try to place it over somewhere on this inclined line. So let's try to zoom that now. So we have just placed it. Now we'll have to rotate it. So go to rotate, see that this copy is switched off. So selecting the same point where we picked from and its opposite, that is C. So let's try to rotate like this. I think it is not it's not picked correctly. So let's try to do that again. So let's try to rotate. Pick it first. You can even try to zoom it as much as possible. So let me try to select this completely, and let me try to move it. See that the copy is switched on. Let me exactly pick at this corner O and place at this 41 degree line. So exactly here. So now it is somewhere it moved correctly. So now let's try to rotate it. Let's try to rotate it. Pick from this point and rotate at this point. Rotate at O. So now it's fine. So now you can just see it is moved correctly. Now there are some some unnecessary arcs and lines over here. Let's try to delete off all those. So which is not required also. Only that 41 degree line was necessary. So let's try to delete off those, or delete off or trim those unnecessary lines over here, because it could just create some confusion. So let's try to, so let me try to maintain only this and along with that you can even maintain that for the 30 degree line, except that all the other things can be trimmed off. Now you can just see all those other lines have been trimmed. So let me first delete off these points and try to name it again, so that it becomes clear. So let's try to name this O, or else let's try to use using move option. Let's try to move it. See that the copy is switched on. So this is O, this is A, this is B, this is C, and this is D. Okay, now let's try to draw the projections. See that so give fit and let's try to draw projections. So using normal line O2, O2 O dash, and A to A dash is here. while B to B dash is here. While C to C dash is here. While D to D dash is here. So now all the projections have been drawn. Now let's try to name it. So you can name it or you can move it again, as I told, because it's very easier in a pyramid problem. Just let's try to just move it. So you see that the copy is switched on. So A dash to A. So E dash to A dash is here, and C dash is here. So we'll have to mention D dash and B dash using this text option. So this is D dash. So this is D dash, and this is A dash, and this is B dash. So actually this is B dash, right? So this is B dash. So see that the points are placed correctly. So actually A dash is here. So A dash is here. So A to A dash, yes, B to B dash, C to C dash, D to D dash, and actually from here, even this is a mid point. Okay, that is fine. All the points have been drawn now. I don't think any point is actually missed. So I think, yeah, one point here, I think O1. So I think that one was actually missed. So from here actually from here to here, I guess, is that point has actually been missed. So let's try to draw that as that point as well. So from here, so till here, so this one will be, if this is O dash, this one will be O1 dash. I think that's not mentioned here even in the second stage, so that's not an issue. Still you can do it in the third stage. So O1 dash. So see that is placed correctly. So now we will have to draw it. So when the observer sees from here, that is from here, this part will completely be visible. So that part will actually be drawn using visible line. So see that one will actually be joined using a visible line. So visible line. So go to A dash, B dash, C dash, D dash, and back to A dash. And then the next thing what you will have to do it is join the boundaries using visible line. So from here, these are all the boundaries that are being joined, and you can just see the lines that is coming within this reference frame will be joined using a hidden line. So this O is the outermost point, O to D and O to B. Actually, that one will be made using a hidden line. So O to D only, not O to B, but only O to D will be made using, because B will be visible, but O to D, that one will be joined using a hidden line. So O to D. So join that using a hidden line. See that. Next one is from O to O dash. That one will be joined using a center line. So this is O1 and this is that is joined using a center line. So that completes the problem. So as I told, this is a very, very easy problem. So I guess you understood that. Thank you. Hello all, welcome to this class on projection of solids. And in this class, let's solve the first problem in pyramids. So far we